There is a shift coming in the vehicle recycling industry as we transition from internal combustion engines being the norm to electric vehicles. The Electric Loops project is an initiative of ELVES, the End-of-Life Vehicle Compliance Scheme in Ireland, and will investigate the reuse and recycling value of electric vehicles. We need to understand which parts can be sold for reuse. What will the demand be like? Are there particular parts with a high recycling value that can be a revenue stream in themselves? These are the answers we're trying to find out through the Electric Loops project.
The first stage of the project was to identify the EV-specific parts in both vehicles. This gave us a list of about 25 parts to remove from each. The EV-specific parts include the electric motor, the reducer that takes the place of a gearbox and transmission in an internal combustion engine, and the AC-DC converter that converts battery direct current in the vehicle to alternating current for the motor. When working with a high voltage EV battery, safety is a top priority for technicians and dismantling sites. Specialist safety PPE and tools, as well as familiarity with each EV, is needed before work can begin on removing the battery and dismantling. We have a multimeter, safety hook, cordons for around the vehicle, insulated tools, insulated and well-fitting gloves and dielectric boots. Both technicians have also completed electric vehicle handling training through the Electric ELVES programme. This is training ELVES has been offering to ATF since 2018. Using mark-specific information on the IDIS system, that is the International Dismantling Information System, they were able to familiarise themselves with the setup of both vehicles for the removal of the battery.
The first step in depollution is the safe shutdown and removal of the high voltage battery. Once the battery has been removed and a short period of time has elapsed to let any remaining energy dissipate, the vehicle is now safe to work on. The rest of the depollution process can now be completed, including the removal of liquids and air conditioning gases.
Outside of the battery, the wider depollution process for an electric vehicle is different. With fewer moving parts, there are less lubricant oils to remove from the vehicle during depollution. No engine oil, for example. However, there are still other liquids that need to be removed, like brake oil, coolant and wash fluid, and the starter battery.
The vehicle technicians then remove the electric vehicle specific parts. Each part is then weighed and photographed and a visual inspection made of its material makeup. The data collected today will be used in the Electric Loops project to list the parts for sale and help recyclers assess the potential recycling value.
The more information we have now on EVs and where the recycling and reuse value is, the better we can prepare and adapt.
The process for the public in recycling an electric vehicle will remain the same, making sure that they know to use an authorised treatment facility, also known as a permitted scrapyard, and getting a certificate of destruction. What will change is the process the recycler takes that vehicle through, removing the battery, depollution and where the value is in the car.
The shift to EVs also means that ATFs like us have already invested in training and equipment to be able to continue the service we provide to the public in recycling their end-of-life vehicles for free and issuing owners with a certificate of destruction.
The Electric Loops project is very much about the future, looking at the value in the vehicles that recyclers are going to be treating in 10 to 20 years' time. The introduction of electric vehicles is bringing a lot of changes to the vehicle recycling industry in terms of what they are processing and also the regulations they will need to abide by. Under the new batteries regulation, there will be a framework to support the reuse and repurposing of electric vehicle batteries, as well as measures to improve the quality of lithium-ion battery recycling. Electric vehicle batteries will also be tracked throughout their life cycle through the use of battery passports, a digital twin of the physical battery. Following an evaluation of the End-of-Life Vehicles Directive, we are also expecting changes to the End-of-Life Vehicles regulations. This will impact the way the ELVs of the future are treated and how we achieve the reuse, recycling and recovery targets for end-of-life vehicles. For a future circular economy, it's important that we have a strong reuse sector and high-quality recycling avenues when products can't be reused or repurposed. We hope that the Electric Loops project will provide the data needed by the industry to identify future reuse and recycling opportunities. The Electric Loops project is a first step in us understanding this future.